All right. Now that we know how to find terms of a geometric sequence and write it a recursive rule, let's graph geometric sequences. So here we want to graph the sequence f of 1 is 2. So there's my first term. And then f of n, the next term, is equal to 4 times, again, f of n minus 1 is just the way we write the previous term. So this means the previous term. So I take the previous term and I multiply it, and there's my common ratio. My common ratio is that 4. Okay, and I want to do that for n's from 2 to 5. So meaning inputs of 2, 3, 4, and 5. This is basically telling me what my domain is going to be. I want to graph it for the inputs of 2 to 5, or the 2 to 5th term. So the easiest way to do this is to create that table. So we know the first term is 2. To get to the second term, I take the previous term, take that previous term 2, and multiply it by 4. So my common ratio here is 4, so multiply by 4. So for the second term, 2 times 4 is 8. To get to the third term, again, I take this previous term, multiply by 4. So 8 times 4 is what, 32? And then now I'm going to grab a calculator because I don't feel like multiplying that all out in my head. So now to get to the fourth term, I take that 32 times 4. So again, I can use my shortcut. So 2 times 4 is 8, times 4 is 32, times 4 is 128. And then the fifth term is 512. So, and it wants me to do it from the second. Oh, sorry. Here it did say from the second to the fifth term. So we went all the way to the fifth term. We're good. So now talking a bit about domain and range. My domain in this case, my domain would be the numbers 1 through 5. So 1, 2, 3, 4, 5 is my domain because we're only talking about those 5 numbers. And my range would be the numbers 2, 8, 32, 128, and 512. Because again, the domain is the set of all inputs and the range is the set of all outputs. So now we need to graph these. So I'm going to graph each of these. But again, we don't include in the in-betweens, like we're not going to include 1.5. So I'm not going to connect the dots. So you don't connect the dots because it's each individual term. Don't connect the dots because I'm just putting in the numbers 1, 2, 3. I'm not putting in 1.5 or 2 1/3. Okay, so we need to look at my domain and range to determine what my window should be. Well, my domain is only the positive numbers 1 through 5. And my range is only the positive numbers 2 through 512. So I really only need quadrant 1. Again, always look to see what quadrant are you going to need. So I only need quadrant 1. And I only need the numbers 1 through 5. So I'm actually going to spread this out a bit because I have a lot of room. I'm going to go over 1, 2, 3, 4 and call that 1. And 2. 1, 2, 3, 4, 3, 4, 5. Okay, so I put in my scale. There's my 1, 2, 3, 4, 5. And now here for my scale this way, I need to get to 512. So what do we want to count by? Maybe every 2 is 100. Will that work? There's 100, 200, 300, 400. I probably could do every 3. So let's get rid of those and let's do every 3. I would have enough room. 100, 200, 300, 400, 500. Or I could have did every 4 or whatever. We just want to make sure that we have it spread out and that we label our scale. You always label your scale so people know what we're counting by. So for a 1, I get a 2. So when I graph that 0.12, it's going to be like right here. When I put in a 2, I get an 8. That's going to be barely more than that. When I put in a 3, I get out 32. So 3 would be 32. Well, 50 would be smack dab here in the middle. So it's going to be, I don't know, maybe right there. 4 is 128. So 4, here's 1. 100 right there. 28, I don't know, maybe right here. Because 150 would be right there in the middle. There's 150. And then 5 is 512. Look how quickly this grows. 5 is 512, right about there maybe. Okay, and it's going to grow a lot bigger, a lot faster. So there is my graph of the sequence. Again, it's just the dots. Maybe want to do the ordered pairs. So this is the 0.12, this is the 0.28, this is the 0.332. So one's 4, 128, and then 5, 512. Okay, so there's my graph. Now we're going to go ahead and do it backwards. So here we have the graph. Part of a geometric sequence is shown. Write a recursive rule for the sequence. So again, to write a recursive rule from the previous video, I need to always list the first term. So how can you find the first term? F of 1, that first term. Well, look at for an input of 1. Look at that ordered pair right there. First term, this tells me the first term, and I can go ahead and write the first term is 160. So for my recursive rule, f of 1 equals 160. Okay, second term is 80. Third term is 40. So I need to find that common ratio. What is my common ratio? Well, grab my calculator and let's divide them. Previous term, one term divided by the term before it, 0.5. Half? So it looks like I'm multiplying by a half each time, times 1/2. From here to here, times 1/2. Yeah, because 80 times a half is 40. 40 times, let's double check and make sure it works. 40 times a half is 20. 20 times a half is 10. Yeah, that seems to work. So to write that recursive rule, if the first term is 160, then every previous term would be 1/2 times the previous term. 1/2 times f of n minus 1. So I start with 160 and I multiply by a half each time. So there's my recursive rule.